So this is the diagram of the rotary air compressor setup what we have in our lab. You will see the video of original video okay later. This one will start from here. Okay, this one 3 what is written here is the air inlet. Okay, air inlet to the compressor. This one is the primary compressor or the low pressure compressor, and this one what you see, this one is the high pressure compressor. Okay, both this low pressure and high pressure compressor are driven by the prime mover, which is the 3-phase induction motor. Okay, so the power input to this motor can be measured. Here we have an energy meter, and by taking the number of revolutions of that energy meter, you will get the power input to the prime mover or the motor. Okay, from here you can see that this is the air intake, and here you will have an orifice meter, and from that orifice meter it will be going two connections will be going to the U2 manometer. So the measuring that head of the difference in head in the manometer, you can calculate the head of air, and thereby you can calculate the air intake. Okay, air intake. And so this apparatus, you can see this one is the primary compressor, low pressure compressor, and after initial compression it will be cooled, the air will be cooled. Okay, so it will be passing through an intercooler, you can see here. So, and this is the intercooler, and to that this line you can see will be the water cooling line. Okay, water will be passing through this intercooler, and the air will be cooled. That cooled air will be that cooled and compressed air will be supplied to the intake of the secondary compressor, and this is the secondary or high pressure compressor in which the air will be further compressed, and after that this you can see is the discharge. Okay, this one is the discharge. After the secondary compressor, the air will be discharged to the atmosphere, and at the discharge you can see one pressure gauge which will indicate the discharge pressure. Okay, there is a valve there which is the discharge valve, and near to that we can see that there is a pressure gauge which shows the discharge pressure, and also there is a setup for measuring the RPM of the system. Okay, we can see that we can measure the using tachometer. We can measure either using we will measure the RPM using tachometer. Okay. Okay, so before starting or doing this experiment, we will ensure that there is sufficient oil, and also we have to ensure that it is started by the discharge valve should be completely opened. Okay, that valve should be completely opened. There should be sufficient oil, and also you will open the water supply, so that then only you will start the motor. Okay, then what we are doing the experiment part, what we are doing, we'll first initially we'll completely means discharge valve will be completely in open position, so that that discharge pressure what we are here will be showing the discharge pressure, that will be 0. And what we are doing, we'll close that valve. Okay, we'll close that valve, and the corresponding pressures you can see here. So you close that valve. For different pressures we will be taking readings like this one. So you will be taking different pressure. You close that discharge valve. Okay, your corresponding pressures you can note here. Okay, so these readings are actually in PSI. Okay, pounds per square inch, and pounds per square inch. At different discharge pressures you have to take readings. What all readings you have to take? You have to take these readings. Okay, these manometer readings from that your YouTube manometer H1 and H2, time for 3 or 5 revolutions of the energy meter disc, and using tachometer you have to measure the RPM at different discharge pressures. Okay, okay, and this much only, this this much only is the observation. Rest of the thing you have to calculate. And And what all you will be finding different parameters such as input power, okay, input power, adiabatic efficiency, isothermal efficiency, and volumetric efficiency of the rotary compressor, and you will be plotting these parameters, that is input power, volumetric efficiency, isothermal efficiency, adiabatic efficiency with respect to the delivery pressure of the like this one, okay, of the for the compressor. And one more thing, so this is the as I said, this is a rotary vane type compressor, and it comes under positive displacement type compressor. That means here this is the primary and secondary compressor, and this is a positive displacement type compressor. That means air is compressed and its volume is reduced, thereby increasing its pressure. Okay, so this one here is as I explained, this one it has this compressor, the primary and secondary. Basically it will be having a diagram, will have a setup like this. We'll have an eccentric rotor, okay, we have a rotor, eccentric rotor, which will be rotating, and to that we have vanes, okay, spring loaded vanes. And since this rotor is eccentric to this casing, we'll see that the air will be get compressed as it moves from the inlet to the outlet. You can see from this diagram also, the rotor is eccentric to the casing, okay, these vanes are spring loaded, and as the air enters, you can see that this volume will reduce as it moves from this part to this part. So as it moves from the inlet to outlet, the volume reduces and the pressure increases.